In this lecture, we will examine flocking. Flocking has to be one of my favourite AI techniques. It involves simple rules that generate complex behaviours that are mesmerising. Flocking can be used to procedurally generate the movement of groups of individuals that like to stay together while moving towards a common goal. The flight of birds comes to mind. But this technique can be used pretty much anywhere you have a group that needs complex moving behaviours that you don't want to program by hand. In this workshop, we'll be creating flocking or schooling fish. To follow along, download the Fish Unity package that comes with this lecture, open up a new Unity file for 3D and bring that package in. When you add it into the assets, you'll find that there is a green fish, a pink fish, and a scene called swimming. If you open up the swimming scene itself, you'll get the green fish all by itself with the camera set up pointing at it. And if you press play, you'll find that that green fish has a swimming animation attached to it. Now, in order to create flocking, you need more than one fish in this case because flocking is a group activity. So we're going to create a flocking manager, and in the hierarchy, just right click in there and add an empty and call it flock manager. This is not unlike the other managers that we've had before for other agents where we wanted to create multiple versions of them so that we can send messages and that and keep track of them. In this case, the fish need to know about each other. So the flock manager is going to create a whole bunch of fish and then be able to tell all of the individuals about the other fish in the flock. Or school, I guess, but I'm calling it flock. Right, so we've got our flock manager, which is an empty. Create a C# script and call it flock manager. And then that script will be attached to our flock manager. Now we're going to open up that script and add in this code. The code is quite simple. It creates an array of fish, instantiates all of those fish objects and puts them at a random location around the location of your flock manager. Right, so first of all, you'll need an exposed variable, public fish prefab, and we pass in our fish prefab here, which can be your green fish or the pink fish or whatever else. You can also do this with cubes, won't make any difference. And then a public num fish that we've got set to 20, but this will allow you to change the number of fish you've got in a particular flock through the inspector. We're then going to create our array of all fish. And so as we instantiate them, they're going to go into this all fish. And then we have a vector 3 called swim limits. This is the range of locations that the fish can be generated within. So this is like a box that is around your flock manager, and it's 5 by 5 by 5, which makes it 10 by 10 by 10 because this is a radius value. And then we'll use these swim limits to generate the location of our fish within that box. So this is all happening down in start. First of all, we create all of the fish and we make the array big enough to hold them. Then there's a for loop that loops around that number of times and each time creates a position to put the fish, and this position is based on the position of the flock manager plus a random vector 3 value that is around those swim limits, so between minus swim limits and positive swim limits, which will give you the range of positions. Now, if you want it to be a bigger box of positions, then you would just make these values bigger here, or you could make them smaller if you want a tight-knit group. Then, once we've got this position that we've calculated, we then put the fish, we instantiate it from our prefab at the position that we just calculated using a neutral rotation. You could also set this to the fish prefab rotation if you've got them pointing in a particular direction. Doesn't really matter. And that will fill up this array. Okay, so if you save that, flick back into Unity, select your flock manager, and you want to set the fish prefab. The fish prefab is not this green fish that's in the scene. Okay, so that's the one that was used to make the initial prefab. In fact, just delete it so that you aren't confused by it. And then grab hold of your fish prefab, which is in your assets, and drag and drop that into the flock manager. We're going to create 20 fish and it will fill up this array here. So press play and there's your 20 fish. And if I zoom out, you'll see them within the confines of the swim limits that we've created. Now, if you want more fish than that, let's say you wanted 50 fish, 50 in here, and press play, and you'll get 50 fish. You can see them, they've all appeared in the hierarchy, and they're all in the inspector under the all fish array. And that's so each fish can find every other fish that's in their flock. Okay, it's time to get the fish moving. To begin, we're going to set up some speed values for the fish, and we'll do that in the flock manager. So we'll make the flock manager a place where we can set all the different variables and that for the particular fish that belong to that flock. And then you can have multiple flocks for different types of fish in your scene. So open up the flock manager script again. What you're going to do is add in some public values as I've got here. First of all, in the inspector, I've just added a little header line, which I guess sections it off and makes it easy to find when you're trying to set them. Then I've got a range here between 0.0f and 5.0f, which will give you a slider in the inspector, and then public min speed and public max speed with the same values for the range. Once you've added in those 5 lines, just save that and switch back over into Unity and click on the flock manager, and you'll find in the inspector that we've now got those settings. We've got fish settings, min and max speed, which you can then change with these sliders as you like. And you'll be able to do that in real time as well and pass through those speed values to the fish. For the fish, we'll now create a new C# file and call it flock. This is the code that goes onto the fish prefab. So drag and drop that onto your green fish. And while we're here, we'll drag and drop it onto the pink fish as well. Just select the green fish down in the assets and check over inspector to make sure that that script is actually attached to it. Now open it up, and the first thing we'll need is a link back to our manager. So we'll create a public flock manager and call it my manager. And then we need a float for the speed. Now in the start, we're going to set speed to equal random.range between the manager's minimum speed setting and the manager's maximum speed setting. In the update, we'll put a translate statement to drive the fish forward along their forward axis or their Z axis. So notice that the value of speed is going into the Z axis. If your fish happen to be facing in a different direction, so if I just go back to my fish and grab a fish. So the blue axis here is facing forward, and that's the one that it's going to be pushing it along. If your fish happens to have a different axis, then you'll have to adjust your code to be pushing it along that axis instead. Okay, so we'll delete that fish and go back to the code and just save that. Then in your flock manager script, if we open that up, after you've created a fish inside of that for loop, you want to set its flock manager or my manager to this particular flock manager. So add this code in. And now both of those files, the flock and the flock manager, will be linked together. Back in the editor, press play and you'll see the results of the code. So you've got your fish that are now going forward. They have random speeds on them. Of course, they're going to go out of scene very quickly. You can see that they're moving at different speeds, if you can get in closer. Yeah, so they've all got different speeds, but they're all moving along their Z-axis. Okay, so now it's time to add in our flocking rules. I mentioned the flocking rules at the start of this section, but let's go over them again in detail. They are: move towards the average position of the group, align with the average heading of the group, and avoid crowding other group members. Moving towards the average position of the group involves taking all the individual members' positions, adding them together and dividing by the number in the group. We can then work out where an individual is in relation to the average location and have them turn towards it. To align with the average heading of the group, we add all the headings of the individuals together and divide by the size of the group. This gives an average vector for individuals to try and align their movement. To avoid neighbours, an individual must be aware where the neighbours are and then turn away from them. Then to calculate a new heading, an individual add together the vector for moving towards the centre of a group, the vector to align with the group's heading, and the vector to turn away from a neighbour. Before we start editing the flock code, we're going to just add a few more values into the flock manager, ones that you can change at runtime so that you can see different behaviours in the fish. And these behaviours or settings for the behaviours will be available to all the fish in that particular flock. So I'm adding in here another range for something called neighbour distance and another range for rotation speed. So once the fish start to get locations that they need to move towards, they're going to have to turn around at some point. And we'll be using a slurp for that, and that needs a rotation speed. So I've added that in there. Now the other thing with this neighbour distance is that you can have a flock of something and everything in that flock might be considered your neighbour, or you might only want to consider like the closest few, like you're, within 1 meter of you as your actual neighbour. So you can therefore modify that and you get different behaviours out of the entire group when they're only sort of considering those immediately around them as neighbours rather than everybody. Now for the changes to the flock, go to your flock.cs code. We're going to create a new method called ApplyRules, and that method is getting called down here in ApplyRules. So there's no other changes to the top, just inside of the update, and then we add in ApplyRules. Now this ApplyRules is doing those 3 rules that we just spoke about with the different vector calculations. First of all, it's creating a holder to get hold of all of the fish in the current flock. So these are the fish that we want to try and find the average position, the average heading, etc. And they're the fish that will be considered your neighbours, or at least they're the whole set and the neighbours will be part of that set, as you'll see in a minute. Now we're calculating the average centre of the group. So we're going to store that in vCenter. Then we're calculating the average avoidance vector as well. So it's not just one neighbour that we want to avoid, it's everybody. And so that's also an average. So we have to calculate all of the avoidance vectors and then average them out. So initially they're set to 0. Then we have this float called G speed, and this is a global speed of the group. And I guess essentially it's an average speed that the group is moving in, and we'll use that in our calculations as well. Then we have a float N distance, which is our neighbour distance. So we're going to have to ask each fish how far away they are and then work out if we consider them to be close enough to be in our group. And so we have this group size counter here that will count how many of the fish in the flock are in our group. So I guess the group is like the smaller section of the flock that is within that neighbour distance value. Now with these values initialized to 0, essentially, we're going to loop through all of the fish in the flock. So we use a for each loop. Then we're going to ask if the current fish, which is going to be this game object here, GO, as long as that's not equal to the fish running this code at this time, then we're going to do the process, because you don't need to find the average of yourself when you don't have to calculate the distance to yourself. So this just makes sure we don't calculate fish's data for itself. Then we work out the distance of the neighbour. So remember, we're looping around this for loop, picking out each fish. And then we're working out the distance with a vector3 dot distance between the game object in our array's position and our position in the array. Our position in the world. And then we're asking if that distance is less than or equal to the neighbour distance, which makes that a fish of interest, one that we're going to consider part of our close-knit group, then we will add that particular fish's position to vCenter. vCenter will be our average position of our group. So therefore we have to loop around and add all of the positions together, and then we divide it by the group size. So at the same time we add it, we also increase the group size by 1. So after this loop has gone through, we can calculate the average. Next, we have an if statement to test our neighbour distance being less than a much smaller value, which I've hard-coded here as 1.0. And we could in fact put this in the flock manager as another distance value. But this is how close we're allowed to be to another fish before we should be considering avoiding it. Now, if this case the distance is less than 1, then the avoid average vector is going to be added to. And so it has its own value plus the vector away from that fish. So the vector away from something, and we looked at this in the crowd simulation when we wanted to move away, was our current position minus the position we want to get away from. And so that adds up as we loop through here as well. Now the global speed is adding together all the speeds of the particular fish from the flock. So we go ahead and grab hold of the flock code that's attached to the fish that we're looking at the moment, and then we grab its speed and add it to this gspeed value. Now by the time the code finishes this for each loop, we've looped through every fish in the flock and we've examined it. If it's considered to be a close neighbour, then we're finding its position and also its avoidance vector as well, and adding all of that up. Oh, and of course the speed. Now, underneath the for each loop, we have an if statement. The if statement is asking if the group size is greater than 0. If the fish is moving along and there is no one around it and the group size becomes 0, it's not going to apply these rules. It's just going to keep moving in a straight line. So if this fish is influenced by another fish or another group of fish, we then find the average to the center. So that's the vCenter vector that we calculated, and we added them all together. Now we divide by the group size, and the speed itself of the fish is set to the global speed divided by the group size. With that information, we can work out the direction that the fish needs to travel in, or the direction the fish wants to travel in. So its direction is equal to the vCenter array plus the vAvoid array minus our current position. Now, if that means that direction is 0, we're already facing in the right direction. If it's not equal to 0, then we need to rotate. And so we do a transform.rotate, and we use our slurp that we've used before for other NPCs, and we do a little rotation according to our rotation speed. And what this will do is slowly turn the fish towards the direction it needs to. It's not going to snap right around to the perfect direction. And it's this slurp and slurping a little bit by little bit and constantly updating your position and checking where you are with respect to all of the other fish that it causes this flocking to occur, as you're about to see. Time on this video is about to run out, so quickly we'll just press play. Make sure that in your flock manager that you do give a neighbor distance and a rotation speed, otherwise you're not going to get any rotation at all, and then you'll start to see the flocking occurring. We'll investigate this more in the next video. Thanks for watching. Please support the development of more superb online learning content by subscribing, and as always, visit holistic3d.com to learn more about awesome games development books and tutorials.